Hey everyone. Okay, very quick introduction to CCE Assist, what it is and what it's for. What it is, it's not a plugin, but it's a sidecar utility. I call it. It runs alongside Cinemacraft Encoder SP3, and the purpose of it ultimately is to improve efficiency and in turn improve the quality. So why is it needed? What's the problem? Well, if we launch Cinemacraft Encoder here and go into the picture settings window, you can see that there is a good number of settings which make a huge impact on the picture quality. You can use the presets. They have presets for CG and I guess that means cell animation and photorealistic images. But if you're using these presets, you're shooting yourself in the foot, frankly, because you're not going to get anything like the level of quality that the Cinemacraft MPEG encoding engine is capable of. For the best results, you really need to tailor these settings to the specific content. For example, if you're encoding grainy 60mm film, the settings are going to be very different to encoding smooth CG material, for example. Problem is that Cinemacraft has so many different picture settings, and finding the best ones before CCE Assist, it took a long time. I'll give you a little. I won't bore you with the example, but just to go through it quickly, what I used to do before I wrote this program was I would use an Avisynth script to trim out a representative sample of the video, maybe like a 100 frame clip or something like that, and I would manually go into this window here. No filters, please. Manually go into this window here, and I would change these quantization characteristics down here. Now, these have a huge effect on the quality of the video. Second only to the bitrate, I would say. I would manually go in. I would try out different settings. For example, I would have to save a profile. Settings A, for example. I would click here, I would apply it, I would encode it, and I would rinse and repeat that whole process maybe 5, 10, 15, 20 times to hone in on what the best settings were. The other thing is also, once those different versions were all manually encoded, I would have to then load up each encoded file, find the same frame, take a screen grab, stick them in a Photoshop document or something, and step through the layers and observe the differences and say, oh, okay, yeah, I see, that one looks better in the flat areas, this one has better retention of film grain, this one has better high frequency detail, whatever. The trouble is with that is it's incredibly inefficient, it's mind-numbing, and by the time I was done with it, it would be 3 in the morning. The more time you have to spend with redundant steps, the less time you're going to have to fine-tune the quality, and that is not okay. So CCE Assist automates that. Not only does it automate it, but it actually takes it a step further now with version 2 in that it draws SSIM quality estimation charts, but I'll show you that in a minute. Right, so let's just give you a demo here. We'll hit browse, we'll find our input file. Let's use Big Buck Bunny because it's open source, it's free, it's a nice reference everyone uses. We need to show it, this is designed really to select an entire feature film, for example, so we're only going to want to encode a small range of frames that we're having trouble with, or a small representative sample. For demonstration purposes, we will use this difficult clip here of these leaves flying everywhere. That's going to be nightmare for MPEG 2. All this high frequency detail isn't going to be easy to compress. So I use Virtual Dub and I find the frame. Frame in is it's displayed down here, it's frame 148. We'll punch that in here, 148. Hit play, we'll find the out point. Let's go up to, why not, let's do this big long sequence here. Look at this, this is going to be really difficult. Okay, so we'll stop at frame 429, fine. We don't need that anymore. Next thing we need to specify is the video system and the scan rate. Now, what we want to do here is get kind of pseudo 24p, as close to that as you can get with DVD, which is 24p plus repeat pull-down flags, repeat field flags, I should say, sorry. So we'll select 24p, but if you have 60i video camera material or PAL progressive or PAL interlace, you can do those too. 24p pull down. The average min max and bitrate here, that's self-explanatory. For the purposes of demonstration, I'm going to do one at high bitrate, one at really low bitrate, and a bunch of others with different settings in between. Now, here we go. This is why I wrote this, mainly. These elusive picture quantization parameter settings, they are actually explained in some detail in the SP3 User's Manual on page 51 it begins. To give you a rough, a quick breakdown, the activity is basically spatial detail. If you have it closer to 0, it's going to retain high frequency, like single pixel details better. If you have it set to closer to 100, it is going to bias the bit allocation towards flat, smooth, low frequency areas. This is CG, so I'm gonna... It's CG, but there's tons of high frequency edges in it, so I can make an educated guess that maybe 20 we'll try. We'll do now with 40, 60, 80, and 100. Now residual is basically motion complexity. Do you want to bias bits towards a complicated motion area or static motion area? Same as above, the closer to 0 is, the more bits it gives to complicated areas. This is quite a complex sequence, so I think a low setting will do. But again, we'll try maybe 50, 80, 100. We'll do 0 just in case, just to show you what the program does. Luminance, I found it doesn't really do much, but let's try it out. 20, 80. We'll just pick some random settings for now. Nonlinear filters, I found that you can quite heavily filter the chroma channels, and maybe less so with CG actually, but you can quite heavily filter the chroma channels, and it will not have too much of it can actually be beneficial for quality with photorealistic material, but let's leave it off for now. Now the viewer window options down here, this is going to show how the results are visualized. You can do horizontal and vertical sharpen. These are enabled by default, and this will all become clear in a minute what these do. Because we're viewing DVD size images like 720 by 480 or 576 if you're in Europe, on today's high-res computer monitors, the image is going to be quite small. And if you sharpen the hell out of the viewer window, this is not sharpening the encode, by the way. It's only sharpening the viewer window that you use to scrutinize the result. It's going to let you... Obviously, there's going to be artifacts, but that's the point. It's going to be... it's going to really amplify the errors that result from the compression. You can add a gamma lift, which will basically brighten the image up and let you see if there's any artifacts in dark areas, for example. Deinterlace, if you're dealing with interlace material, we're not, and this is new for version 2, and I find this really useful. It draws an SSIM quality chart. Enough talking really, I'll show you what it does. We've plugged all our settings in. We've chosen that we want to encode 5 different versions, which is the max with the current version of CC Assist, and we want to encode these frames from this file with these settings. Hit go. And don't be scared, for a couple of seconds it will hijack your keyboard, it will hijack your mouse, it'll plug all those settings into CCE, just like that. And it will go through and encode them all. So sit back, let it do its thing, and in a moment we're going to have something to look at. Right, so it's encoded 5 different versions, and you'll see that it's now skipping through them all, and it's generating quality charts, which we will be able to view in just a minute. Don't interrupt the Verge.viewer, obviously. Okay, so it's done its thing now. First thing we'll look at is the viewer window. This is VirtualDub. If you're not familiar with it, you'll see the images repeated twice. Just ignore this one on this side. For what we're using it for, we don't need it. You can also right-click the image and enlarge it, and you can step through it with the left and right arrow keys. So this here shows you the results interleaved. We have frame 1 of the source, frame 1 of version A, frame 1 of version B, which would have a lower bit rate. You can see the distortion right there. 1C, 1D, 1E, 2 source, 2A, 2B, 2C, you get the idea. You can scrub through the video here. You can even hit play if you want and see it's probably not very useful, but it's interesting to look at. Then also you can see that the information is printed up here. This is the SSIM rating here. If you're not familiar with SSIM, it is a metric which estimates the way in which the human visual system is going to perceive the quality. It's not flawless. Generally, it's better regarded than older methods, like which are less psychovisually aware, as far as I know. So if you have an SSIM rating of 1, then that would be the encode that is a visually perfect result, a visually perfect match for the source. We have 0.97, which is pretty good going. That is CinemaCraft for you. You can see the one we did at the low bit rate is 0.8. And also it also prints at the top the quantization parameter settings that were used to get that result. You'll remember that we turned on the sharpening before in the CCE Assist side. Now if we want to change those settings, we can. We just close the viewer window, reload CCE Assist, and there's a button down here called View Last. That will just take you back to the viewer window without redoing all the encodes. Let's say I want to add the gamma shift as well to see what's going on in the dark areas. I just run it, check it, and boom, there you go. This isn't really, there's not much dark areas in this content, so that's probably a bad example, but you get the idea of how it works. Here's the other new feature for version 2. This is the quality chart. So as you can see here, the version B, which we did at low bit rate, this is the SSIM of each frame in the source clip. Version B, which we did at low bit rate, is doing quite poorly in quality at the start, and it seems to be that around this point, which is frame 60 of the source, that it actually manages to nearly match the other one in terms of quality. And if we find that frame in this the viewer window here, you can see why that is, because it's got a lot of low frequency detail. It's not a difficult frame to encode at all. But you'll see the quality soon drops when you have anything kind of more complicated. By the way, you can click and drag to zoom in these, and you can also disable the various different versions down here. So version B is clearly at the running edge. Did that as a kind of control, if you will. Kill that. We can see the next lowest one is version E. Get rid of that, and then the other settings are actually quite similar to each other. But if we drill further, we can see the best of them all is version C. And if you're into video compression, you'll probably have figured out by now that the kind of peaks and dips you see in this chart here, the peaks are the iframes, where the entire image is stored without temporal redundancy, and these will be the P and B frames in between. The spikes of quality of the iframe is completely normal for a video codec which is using temporal redundancy. So yeah, there you have it. We found that version C is computationally, the computer thinks version C is the best. Do check it with your eye, because SSIM isn't flawless, but as you can see, this is a really gorgeous looking encode, actually, some pretty difficult material, and hopefully with CCE Assist as a tool you can make the encodes even more gorgeous. There you go. So shoot me an email with any questions, and I'll see you later.